This presentation is going to show how to work with non-fungible tokens, which also frequently go by the acronym NFT, using the Simple Ledger protocol on the Bitcoin Cash blockchain. So non-fungible tokens are like the CryptoKitties is the typical example, where each cat was a unique icon or character or piece of artwork, and it got really popular on Ethereum. But some common use cases for non-fungible tokens include like unique items in a video game is a really common use case. One use case that I think is really good for NFTs but is not frequently discussed is concert tickets. So for instance, row B, seat 24 is like a unique chair or a unique seat, and so an NFT would be more appropriate there than a typical fungible token, because you wouldn't, you'd want to specifically isolate a specific seat and have the token represent the seat. Another common example is like artwork. So artwork is a general category, but the Mona Lisa is a very specific piece of artwork, and so that's what NFTs or non-fungible tokens are used to represent, as opposed to fungible tokens. Is there's still a token that can be sent and traded, or like baseball cards. That's another good example of NFTs, where you may have several of the same type of baseball card, but the one that's like folded and earmarked is clearly not the same as the one that's in pristine condition. And so these sorts of non-fungible assets are what non-fungible tokens are used to represent on the blockchain. So there's a couple prerequisites before I jump into the demo here and show the developer tools on how to use it. First of all, what you want to do before you start this is go to fullstack.cash, scroll down to the examples area, and watch this video, this introduction to fullstack.cash. This is where I introduce the BCH.js JavaScript library that I'll be using in this demonstration. And I also show how to create normal SLP tokens with it. And you really need that prerequisite knowledge before you start to work with non-fungible tokens. Also, because we're using fullstack.cash and the BCH.js library, you will quickly get warning messages about exceeding the rate limits if you don't create a free account and get a JOT token. The easiest way to do that is to simply go back to the fullstack.cash homepage, click this sign up button, and create a free account, which will increase your rate limits from 3 per minute for the anonymous tier to 10 per minute for a free account. Or if you really don't want to create an account, you can just use this demo account. It's demo@demo.com with the login name or with the password demo, and you can log in. And right here is your JOT token. And in fact, June 25th, it looks like this is still valid. But if you want to get a free JOT token that unlocks 10 requests per minute, you can just hit this get API token, and it'll refresh it. And now I have a brand new token that won't expire until July 6th. So we can go ahead and use that token. I'm going to go ahead, I already have a BCH.js token. What you want to do with it is described right here. I'm going to set it to an environment variable. So if I go echo BCH.js token is the environment variable. This is the JOT token that I'm going to be using. This is my personal JOT token. It's okay if you want to copy this and use this because it's going to expire in a few days anyways. And so what you want to do is when you get this JOT token, you're going to want to select it, copy and paste it, and go export BCH.js token equals paste your JOT token, and that will set it. And then you can confirm that it's been set up by doing that echo command with the $sign. I'm using Ubuntu, but this method will work on a Mac, and I believe it also will work on a Windows machine. But yeah, just for frame of reference, I'm using Ubuntu Linux in this example. And the place to find the examples that I'm going to walk through, again, you can go to the examples page and click on this View Examples on GitHub button. And this is the BCH.js examples repository under the Permissionless Software Foundation GitHub group. This is what we're going to work in. And there's a really excellent README here that describes some of the prerequisites that I mentioned before, and you can get to it by going to the Applications folder, SLP for Simple Ledger Protocol, and NFT for Non-Fungible Tokens. And then these are the examples that I'm going to walk through in this video. And here's an explanation for the non-fungible token workflow and sort of core concepts. And so let's go through that, because that's this other prerequisite that you're going to need to know. Because non-fungible tokens using the Simple Ledger Protocol on the Bitcoin Cash blockchain, the workflow is quite a bit different than the ERC, 724? I might be getting that wrong. But whatever the ERC specification is for doing non-fungible tokens on Ethereum. The concepts are the same, but the actual workflow as a developer for creating and working with these tokens is slightly different. So I'm going to go through that right now. So again, if you go to the examples, applications folder, SLP, NFT, this is where we're going to be. And I have a link here to the NFT 1 specification, which I'll just show this real quickly. This is the specification that governs the use of non-fungible tokens using the SLP protocol, and this is the specification that these examples adhere to. And the way it works is first you create what's called a group token, and this group token is not a non-fungible token. It's basically the raw ingredient from which non-fungible tokens are created. It's analogous to a stem cell in your body. That it's this amorphous cell that could become any other kind of cell. It hasn't really chosen a specialized cell like a blood cell or a nerve cell or a bone cell. It's a stem cell. It can become any of those things, but it's none of those things yet. That's what an NFT group token is. And then to create the actual NFT, the non-fungible token, that's kind of called an NFT child. And you do it by burning one of these NFT group tokens. And by consuming it, that's part of the protocol that allows you to create these actual non-fungible tokens. So it's really important to understand this two-step process. So for example, a group token is like... it represents a class of items, so like swords in a video game, or paintings, or concert tickets. Whereas when you create the child represents a very specific thing, like Excalibur, which is a specific sword, or the Mona Lisa, which is a specific painting, or Row B, Seat 24, which is a specific ticket. So that's the difference between the group's token and the child NFT token. So that's really the basic concept. It's really important that you understand that. Otherwise, a lot of this stuff is just not... how it fits together won't make sense if you don't understand this basic concept that's captured in this picture here. Okay, so those are the prerequisites. So let's get into this demo. So what I'm going to create in this demo is I'm going to create two non-fungible tokens. I'm going to create a group that represents swords, and I'm going to create two non-fungible tokens. One for the green dragon sword and Excalibur, which is another kind of sword. I was trying to go for the green dragon in Crouching Tiger, Hidden Dragon, but I had a hard time finding a picture for that. But I found these pictures on the internet, and I uploaded them to IPFS. So this is the image that we're going to tag with our group token for swords, and this is the image that we're going to use for Excalibur. And we're going to essentially attach this artwork to the token, and then this is the picture for the green dragon sword. And the way I uploaded these, if you look at the URL, you can see that this part is the same for all these pictures. This is just an IPFS gateway. And if you're unfamiliar with what IPFS is, it's the Interplanetary File System. It's a new way for doing file sharing. And the way you locate a piece of content on the IPFS network is with this hash. And so we're going to add this hash to our tokens. And so anybody who has one of these tokens, or their wallet software really, can look at the token and get this hash from it and know where to locate the artwork and pull it down. And so each one of them has this unique hash. And so I'm just using these as examples. And the way I uploaded this is I used the new IPFS upload service on fullstack.cash. So it's at ipfs.fullstack.cash. And I'll just briefly show how this works. If you upload an image, like let's just take this Excalibur image and submit it, it's uploading it right now, and then it will present you with an amount of Bitcoin Cash to pay. This is equivalent to 1 penny at the spot price at this moment, and a Bitcoin Cash address to pay it. And then if you send this amount of Bitcoin Cash to this address, your file will then be uploaded and hosted on the IPFS network for 1 month. And so if you're watching this video after a month of me publishing it, you probably won't be able to find this artwork. And that's okay, because I'm not trying to make it preserved forever. I'm just giving a demonstration. But this is how it works. It takes about 2 minutes. You can see this swirly animation. So if you try this, just be patient. It takes a couple minutes for the software to detect your payment and upload it, and you'll get a notification with a link to your artwork or whatever file you want to upload to IPFS. So anyways, that's how I got these images up on the IPFS network, and that's where we're going to be pulling these images from. And so what we're going to do is we're going to create first an NFT group token. Then we're going to just practice sending that NFT group token. We're going to send it back to ourselves, but you'd use the same process to send it to someone else. We're going to consume that group token and create an NFT child token. Then we'll send that child, again, back to ourselves, but same process you'd use to send to someone else. Then we'll mint another group token and repeat the process to create our second sword. So let's dive right in there. So again, we're at this BCH.js examples repository. And what you'll want to do, I'm going to do this from scratch, BCH.js examples. And let's see, in the temp directory, let's clear this. So I'm in a brand new directory. I'm going to git clone the examples repository. I'm going to go into that examples repository and go npm install to install my dependencies. And this might take a minute, so I'm just going to pause the video. Okay, so that completed. And just to be thorough, I am using Node version 12 and NPM version 6 in this video. Okay, so now that that's installed, again, we'll go into the applications, SLP, and what we need to do is we need to create a wallet. Now, when you look at this code, everything is going to be, by default, using testnet. And the reason I use testnet is because brand new people who use this can get testnet coins by going to fullstack.cash and the examples page. This is the examples page. And this link right here, testnet faucet, you can go here and put in see how it says BCH test? You can put in a testnet address and get some free testnet bitcoins. But in this demo, I'm not going to use testnet. I'm going to use mainnet because there's not a whole lot of support for testnet. So I'll leave it up to you. If you want to use testnet, you can get free coins. That'll let you go through the code, and that's what the code's going to be tuned for out of the box. But in this demo, I'll show you the code where you flip the switch between mainnet and testnet. I'm going to be using mainnet. That means I'm going to be spending real Bitcoin Cash. And so if you want to do that too and follow these steps, you'll need to obtain a little bit of real Bitcoin Cash. So now that I'm in the SLP directory, I'm going to go into the create wallet directory and hit npm start. And this is going to create a Bitcoin Cash wallet for me. So if I look at this wallet.json file, I have a Bitcoin Cash address. This is the private key, essentially, this 12-word mnemonic. This is what you would normally not want to show anybody, but because it's a demo, I'm going to drain the money from this when I'm all done. This is the address that I need to send a little Bitcoin Cash to, and I'm going to send bin run send. So what I'm using here is this SLP CLI wallet. I use this as a prototype wallet, and it also uses BCH.js. And if you want to use it too, you can go to fullstack.cash and go to examples, and right here, SLP CLI wallet. You can find that there. I use this as a rapid prototyping wallet for doing this sort of stuff. And it has this has all these commands, and you can find out more information on a command by going help or going help send, and it'll tell you all the different command line arguments that you can use. But right now I'm just going to use this to send money. I have a wallet called Trash. I'm going to send 20,000 Satoshis, which I'll find out how much that is at the moment. And I'm going to send it to our new wallet. And while that's processing, I'm just going to bring up there's several block explorers on the internet. I like to use the one on Bitcoin.com. It's got a bunch of features that we're going to use in this demo. And I'm just curious what 20,000 Satoshis cost right now. I'm going to guess it's about 5 cents. So okay, there we go. We sent that. How much is that? We sent it to this address. So yeah, I was right. It's about 5 cents. So I just sent about 5 cents. So it doesn't, and that's going to be more than enough to make these tokens. So that's one really nice thing about Bitcoin Cash and the SLP token protocol is it's extremely inexpensive. I didn't want to do that. Okay, so now that our wallet's funded, we can, and I'll go into the NFT thing, but when I'm all done, I'm going to use this burn all example, and I'm going to, anyways, I'll show that when I'm ready, but I'll run this to burn all of my tokens that I created and send all the Bitcoin Cash back to my wallet. So the only thing that I've lost is going to be the miner fees, which is going to be a fraction of a penny. Okay, so but in this SLP directory, I'm going to go into the NFT directory, and these are all the examples that we're going to run. So first, let's create this NFT group token, which if we go back to the README, that's this here. We're going to create one of these group tokens. So we're going to create a group called Sword, and it's just a general class of swords. So if I go into the Create NFT Group, you can see all these directories. They have a package.json file and they have a .js file, and you can run them by running npm start. Now I want to edit this file before I run it. So I'm going to open it up in my text editor here. I like to use Atom text editor. So create NFT group. Okay, so here's the flag where you set mainnet and testnet. So when you download this code, this should say testnet. I run everything on testnet. You want to change this to mainnet if you're going to use real Bitcoin Cash like I am in this demo. And if you scroll down, this is really important code to understand, but I'm not going to really go into it in this video. This is how you construct a transaction. It's pretty busy, but once you get comfortable with this pattern, all of the examples use this exact same pattern. So I'm not going to go into the pattern right now in this example because I'm pretty sure I went into it in that first video introducing the BCH.js library and how to work with SLP tokens in general. This config object is where we're going to set the information for our group token. So I'm going to call this the sword token, or swords. And so I'll give it a ticker name of sword. You can put in any document URL you want. This is typically a website, so I'm just going to point to fullstack.cache with this. There's one other... Oh, you know what? I should show you the documentation. That's probably one of the things we should have started with. So to look at the documentation, go to fullstack.cache, scroll down, go to this documentation page, and then go to... I have documentation here for the BCH.js JavaScript library, the BCH API, REST API, and then this is a introduction to the cache stack. It's just a general explanation of a framework that fullstack.cache is based on. It talks about this concept of being a full stack developer and what that means in light of working with Bitcoin Cash. So I definitely recommend reading this if you haven't. But this is the documentation for the JavaScript library, and we're going to scroll down to the SLP NFT section. So there's SLP. Here's the SLP NFT section. This is what's going to generate the op return, and I'll go into that in more detail. And we're going to use this generate new NFT group op return. This is what we're using in this example. You can see it right here. This is what we're going to call. So here's an example of how you'd use it, and I'll talk about the op return here in a second after we run this example. But there are options. Oh, you know what? I need to better document the document hash. The whole reason I was showing you that is there's this other property called document hash, and it's optional. You don't have to put it in. But this is where I'm going to put the hash for our sword icon. That's going to go right there. And, okay. So we're creating a sword group. This is the icon that it's going to use for the artwork. We're going to create a minting baton so that we can create additional tokens. We're just going to create one token for now with this initial quantity. And we're going to create a minting baton so that we can create additional tokens later. Okay, so those are the only changes I really need to make. Let's run this. Oh, there's an error. Document hash must be 0 or 32 hex bytes. Oh, that's a shame. You see what I'm using is I'm using an IPFS hash, and this is expecting a Bitcoin Cash hash. That's unfortunate. So I won't be able to use this. So okay, ignore what I said about the document hash. I'm going to instead use this document URL. In fact, I'll just put in the entire thing. Okay, there we go. I'm going to just put in the entire link to the artwork. That makes it really obvious. Okay, there we go. So this link here will take you to this transaction we just generated on the blockchain. You saw that little animation here. It said it's validating, and then it just determined that it's valid. This is why I like the Bitcoin.com block explorer, is it decodes a lot of stuff for you, helps you with debugging. So it successfully detected that this was a valid SLP transaction using the NFT1 group specification. It's a Genesis type of transaction, so we're creating a brand new token. And here's the link to our... We can click on that to get to our artwork. There's our artwork right there. And here's the actual op return. So if you don't know what an op return is, you can have one op return per transaction, and an op return is a way of adding just arbitrary text data to a transaction. And this is used in the SLP specification for the tokens. This is how there's two parts to an SLP token. There's a colored coin, and then there's this op return that describes the token transaction, if it was a send or a mint or a genesis, and how this token is related to other transactions. And so we can see here that we created one sword token and we created a minting baton. Okay, so now we've created our group token. We're just going to send it to ourselves, but we'd use the same method for sending to other people in this send group example. And one thing that's really critical to understand in SLP is this idea of a token ID. And the token ID, which is what differentiates one token from another, or class of tokens, is the token ID. And that's the transaction. It's the first transaction that was a Genesis transaction. That's the token ID. So our token ID here is D5, DB. It's the transaction ID right here, this number and this number. Only in the Genesis transaction will these two numbers be the same. In future transactions, this transaction will change, but this token ID will always stay the same for this token. And then this will change when we create our child tokens. But so right now, in order to send it, you have to know the token ID. And so I'm going to paste that in right here. So that's our token ID. We have one token. That's what we're going to send. That's our quantity we're going to send of this token ID to this address. And so if I wanted to send it to somebody else, I'd put their simple ledger address in here. But if you leave it blank, it'll just send it back to it yourself. And again, we're going to use mainnet. This will be testnet by default, but I've already changed this to be mainnet. These are really, most of these examples are like this, where you just need to change a couple things up top here, and it should be good to go. The Genesis and the Mint transactions are different, or the Genesis ones, where you have that config object that you need to change to customize it for yourself. Okay, so now that we've got that filled in, we can go to the send group, and again run npm start. Looks like we filled everything out correctly. Let's look at it on the blockchain. So you can see here it's been broadcasted. It's not yet confirmed. It is valid. So if you make a mistake in this code, if you change this for yourself and you make a mistake, you'll know pretty obviously that it's a mistake, because this will say invalid. And then you can use this link here to go to the SLP Explorer, and that's a little better about telling you what went wrong with your transaction. And it'll probably burn a token. So that's why you want to do this sort of stuff on a test token before you do it for real, so that you don't burn real valuable tokens. And so let's see here. We've got, like I said, we've got a different transaction ID, but the token ID stayed the same, like I said it was going to. We still got all the same information about our sword. We're still just dealing with the group token. And so this is how, say, if you had an IT department or you had multiple developers, one person might specialize in creating the tokens and the minting and holding the minting baton, and then they pass this group token on to maybe another department to actually make the NFTs. That's sort of what this workflow would go towards. So again, we just transferred a group token here to ourselves, so it's not terribly interesting, but this is how you would send a group token to someone else. Okay, so we've done that. We've sent an NFT group token. So now we're going to consume this group token and create the actual NFT, which we call an NFT child. So if we open up the NFT child example, this is another type of Genesis transaction, but we're going to need our token ID for the group token. We only have one. We're just going to burn one. And again, we're going to send it back to ourselves. If you wanted to send the child NFT to someone else immediately after creating it, you could put in an address here. Again, mainnet. Since this is a Genesis transaction, there's one of these config objects down here, right here. So we're going to call this Excalibur, and I'll just, for the ticker, I'll do the same thing, Excalibur. And like in the last one, I'm going to link to the specific artwork right here in the document URL. Okay, and so now we can run this example. Create NFT child. Okay, so now we can look at this on the Block Explorer. It's validating. Okay, it shows as valid. So you can see this is the Genesis transaction for our group token, swords, and it has a link to the generic artwork, this one. This is our new Excalibur token, so this represents a specific type, a specific sword, and it has a link to its own artwork. It has its own token ID, and you can. But there's a path here to the parent. You can click on this View Parent, and that'll link to the original to this Genesis transaction of the group. So that's its parent, and we can see here we just created one token. Here's the group token that we consumed. That's this input here, and we have this one output that's Excalibur. So this would be like so this is now an NFT. This would represent a specific sword like Excalibur. Okay, and so then let's send this Excalibur token. So let's say we want to pass this on to another player, and we have their Bitcoin Cash address or their Simple Ledger address. We're going to send this child token. And what's really important here is that we need to use the token ID of the child, which is different than the token ID of the parent or that group token. These children, the real NFTs, the child NFTs, they have their own token ID. And this is part of what separates this NFT stuff from the normal SLP tokens. So again, we only have one, so we're only going to send one. We have the token ID of the Excalibur sword. We're going to send it back to ourselves. That's why. But if we wanted to send somebody else, this is where we put their Simple Ledger address, and we're using mainnet, and that should be all we need to do. So send child. We're going to run that. No token UTXOs for the specified token could be found. Oh, you know what? I did not save the file, so that's why it gave us the error. So now that I saved the file, there we go, and we can check it out in the Block Explorer. It's validating. Okay, so we were able to generate a valid transaction. And we consumed one Excalibur token, and we produced one Excalibur token, and just sent it back to ourselves. But this would be the same process that you'd use to pass one of these NFTs to someone else. Again, here's the artwork and the token ID. These things don't change. They're essentially set in stone at this point. Okay, so now that we have created a group token, consumed it to create our child token, we want to create another unique item, another unique sword, the Green Dragon sword. And so in order to do that, we need to create another group token, and we can do that because we have the minting baton. That's this output right here. We have the minting baton. So we can do that by going to the Mint NFT group. We go to Mint NFT group. That's already the minting baton's in our wallet. And we need to, this is going to use the original token ID of the swords group token. So that's going to go here. We could mint more if we wanted, but for these examples, I'm just going to do one at a time, and I recommend that you do one at a time, because when you start dealing with multiple tokens at a time, you need a lot more code and logic and stuff. So for these examples, just learning the ropes and the code behind it, just do one at a time. So we're going to create another sword group token. And so we put in the token ID, we have one, we're going to send it to ourselves, and we're on mainnet. So we're going to mint another one. Okay, looks like it was successful. Let's check it out on the Block Explorer. Validating. Okay, it's valid. So you can see here, we consumed the minting baton, and then we created a new minting baton and passed it back to ourselves. Oh, it looks like we created 10 swords. How did that happen? We had one there. Oh, there we go. Okay. Typo. I'm going to fix this so that it's not like that for you. I'm going to put this variable. Right here. There we go. Okay, so we created 10 swords, but let's just pretend we only created one. Now this is why it's really helpful to look at the Block Explorer to check your work. But we created these group tokens that we can then consume to create additional NFTs. And again, these new tokens, they're pointing at this artwork, which is the icon for our group of swords. Okay, so now that we've minted another group token, we can consume it to produce another sword, another specific NFT sword. So we're going to go back to this create NFT child, and the token ID hasn't changed. We're just going to create one child. We're going to send it back to ourselves. We're going to use mainnet. We're going to go down to this config object, and we're gonna. This is where we're going to customize it for the green dragon. We'll get our link to the artwork here, and we'll put that into the document URL. Okay. So now we're good to go. We're going to go create NFT child. We're going to run this again. Look at it on the Block Explorer. Okay, here we go. So it's validating. It's valid. So we've got our green dragon NFT. We've got a link here to the artwork. And so this is an NFT for the green dragon, not to be confused with the NFT for Excalibur, but they're both related to the sword group token. They both have the same parent, and you can see it has its own token ID, which is different than the Excalibur token ID, 232 for Excalibur, B46 for the Green Dragon. So they have their unique artwork link and their unique token ID. So a wallet can clearly tell the difference between these two NFT tokens. And yeah, so that's it. We now have, and we still have these additional group tokens that we can use. We can mint more tokens. We have additional tokens we can use, and we can consume additional group tokens to create additional NFT tokens for very specific types of swords. and we can keep minting them. We can also burn the minting baton. I'm not going to show that, but there's different ways to burn the minting baton, which makes it impossible to create any more group tokens, and so it can create a fixed amount of these NFTs. And so that's pretty much the demo. I walked through the whole thing. Again, let me just direct you to this README in the BCH examples application SLP NFT, and we followed this workflow, and it's described here, and we worked through these examples in this video. So if you go through all of this yourself, you can get a more intuitive understanding of this NFT process and how to create NFT tokens on the Bitcoin Cash blockchain.